Hi and welcome to another instrument choice support video. In this video, we will help you to understand infrared thermometers. Infrared thermometers take surface temperature measurements from a distance without having to touch the object you want to measure. This makes them perfect for measuring hot, moving, sterile, or hard to reach places. Before we explain how infrared thermometers work, we'll explain some of the factors that come together to help give a temperature reading. The first is infrared energy. Infrared energy is a frequency of energy on the electromagnetic spectrum. Infrared wavelengths are longer than visible light and are so generally invisible to the human eye. Infrared light is emitted from the surface of all objects. For this reason, an IR thermometer is usually used in tandem with emissivity values to arrive at a temperature measurement. The second is emissivity. Emissivity is the measure of how effectively a surface can emit energy as infrared radiation. The emissivity scale is a value ranging from 0 to 1. A value of 0 is attributed to the perfect reflector, and 1 is an object that absorbs all incoming radiation and does not reflect any. To ensure accurate results, it is important to know the default emissivity setting on your IR thermometer, along with the approximate emissivity of the surface you wish to measure. Most items fall within the emissivity range of 0.95. As a result, most infrared thermometers will have a default emissivity setting of 0.95. The third factor is the distance to spot ratio. The distance to spot ratio is the size of the area being measured against the distance of the thermometer from the sample. In simple terms, the area being measured becomes larger as the distance increases. Inversely, the area being measured will become smaller as the distance decreases. Knowing your distance to spot ratio is important. It will help to ensure accuracy by helping you avoid taking measurements from outside of the desired area. Here's an example of a distance to spot ratio of 12 to 1. The IR thermometer measures the temperature of 1 inch diameter spot when you are 12 inches away from the surface. The spot size will increase by the same ratio the further away the measurement is taken. So 24 inches away will be 2 inch diameter, 36 inches away will be a 3 inch diameter, and so on. So why does the distance to spot ratio matter? It all depends on the distance and the size of the area you wish to measure. Need to measure a small area from a distance? A higher to distance to spot ratio will be necessary. Need to measure something at close range? A low distance to spot ratio will fit this application. Don't confuse the visible red laser for the infrared beam or for the spot being measured. The infrared beam is invisible and the laser is simply there to act as a guide. On single point IR thermometers, this is usually indicating the center of the measurement. Check your thermometer's instruction manual for more information. So, we've covered infrared light, emissivity, and the distance to spot ratio. So how do these factors come together to give a temperature reading on an IR thermometer? It can be explained relatively easily. When you press the trigger, the infrared thermometer measures both the infrared radiation and the emissivity value of a surface. The surface size measured is determined by the device's distance to spot ratio. The thermometer then focuses the IR rays onto a lens and tunnels them through to a detector known as a thermopile. The thermopile converts the infrared signals into an electrical signal that is then displayed as units of temperature. It all sounds complicated, but this happens almost instantly. So, when choosing an IR thermometer, there are a few things to consider. These are the surface intended for measuring. Will it be shiny? You may require a device with adjustable emissivity. The distance to spot ratio. Will you be measuring a small object from a distance, or will you be measuring at close range? In addition, another two things to consider are accuracy. Ensure the accuracy of your instrument is reasonable for intended use, and temperature range. Be sure to check the thermometer's temperature range and that is within the range you plan to measure. We hope that you found this video on understanding IR thermometers helpful. Thanks for watching.